there are fantastic basic research that's ongoing, which is going to lead to new developments and potentially to lead to targets for new cures. I mean, that's what we ideally would like to have. But even now, we're currently going through a number of clinical trials. So there's clinical trials being done in pretty much every country in the world. Some of them are more standard, and that is they're using different chemotherapy regimes. Different places will currently use different treatments, and we still don't know absolutely the best one. And so some of the more standard treatments are currently being trialled. But there's a lot of really interesting experimental work that's being done at the moment. So I can speak very much for what's happening in Australia. Within my institute, not myself personally doing the work because I'm a basic scientist, so I tend to do more of the laboratory bench work. But some of our clinicians are doing a study, for example, on CD40, and this is a molecule which stimulates the immune system. So this is, the white cells in your body that fight off infection, etc. And they found that if you can activate the immune system and then stimulate or treat with chemotherapeutic agents, that you can get very good responses against mesothelioma in animal studies. So now they're actually taking that into the clinic and actually doing clinical trials on that. And so that's a really hopeful, different sort of something a bit different that's being done at the moment, and that's within Perth. Personally, from some of my own studies, I'm interested in looking at a particular pathway called the sonic hedgehog pathway. It's a developmental pathway, so that it is activated when we are developing, when we're born, or before we're born, whether we're an embryo. Now what we're finding is a lot of these developmental pathways are being reactivated in normal tissue repair and also in cancers. And this particular pathway, called the hedgehog pathway, we have shown in our preliminary studies, and this was from a grant that was actually provided by MAF that started a lot of this, and we've got some subsequent funding from this, that this pathway seems to be hyperactivated in mesothelioma. And from these studies, we're now planning with Hedy Kindler, who's a person in Chicago. I think a lot of people know her. She's a very good mesothelioma doctor. We're planning doing clinical trials using some inhibitors to this pathway that are currently available and being used in experimental trials for other cancers. And so this is pretty exciting because I really think that we may not affect all mesotheliomas, but a proportion of the ones that we see may be helped by this. So that's something to look forward to in the future. Other studies that have been done in our own institute, for example, there's studies being done on PET screening. So PET is really, what it does is it's a way of looking at imaging your whole body, and you inject a radioactive chemical that's linked to something that is targeted to a particular cell in the body. And the classic is glucose. So what they do is if a radioactive label hits glucose, any cells that are rapidly turning over or metabolizing quickly, it gets incorporated into. And cancers are one of those cells that rapidly metabolize. So that's great. So we can identify cancers in the body, and it's often used. So if you know you've got a malignancy, they'll give you this therapy, and well, it's not therapy, it's sort of an imaging, and they'll be able to see whether there's other cancers anywhere else in your body. So that's interesting. But what we're doing now is taking that experimentally, and Rosalind, who's in charge of running this work in Perth, what she's doing is she's labeling it with other molecules. So for example, they're using a molecule which can look for dividing cells, rapidly dividing cells. And again, now they can identify where the most divisions are happening, or which cells are dividing mostly in the body. And if they see tumours that are actively dividing rapidly, that's very important for prognosis, because you don't want to have a tumour growing rapidly. So that's been used for looking at prognosis studies. There are other ones where they're looking at, for example, markers of apoptosis, and what that is a way that cells die. And so they can identify which cells are dying and how they're dying, again to give us more information in real time about what's happening in the patient. Because up to now, really all of these sort of studies are done in animal models. And we can only go so far in showing what's happening in animals. We need to look into humans. So these studies are very important. And so I think this whole PET analysis and potential of PET analysis for imaging and understanding more about the human tumour will be very important. But these are just a few little studies that are ongoing. There are worldwide enormous amount of studies. Like I said, most of them using different chemotherapeutic regimes, but there is a real emphasis now on targeting specific pathways in each individual. So they will do a screen of a particular individual, maybe a genetic screen, look at the DNA or the RNA. They'll identify a particular pattern that may be expressed by that particular tumour, and then say, well, a particular pathway is activated in that tumour, and we'll then treat that particular pathway. And so there's a number of different cell signalling molecules that are being targeted specifically in different patients because they think that they may actually be of use. That's not just in mesothelioma, that's in lots of different cancers, but we're also seeing that now in those sort of studies in mesothelioma. So hopefully, in the not so distant future, we're going to have something that's going to be a bit more universally useful, although we may find things that are more specifically useful to each individual patient. And fortunately, because mesothelioma is not in a big number of people, we can probably do more specific type analysis rather than with the more common cancers. It would become too expensive. So it's good to have research linking very closely now with the clinic, that we can actually take what we're learning from the bench, from the basic science, and then apply that into the clinic for experimental reasons, and hopefully with an positive outcome, which will either ideally cure mesothelioma, if not cure it, at least slow it down, and so that we can get longer survivals.